Okay, Alex and Joanna went on a 100-mile canoe trip with their class. On the first day, they traveled 28 miles. What percent of the total distance did they canoe? Well, let's start with the word percent. What's the definition of percent? Well, literally, it means per 100 or out of 100. But one way I like to look at percents is a percent is equal to some part of a whole. Now this will give you a decimal like 0.2 instead of 20%. And so we can multiply by 100, and that just converts the decimal into a percentage. So in this case, we have the part is the 28 miles and the whole is the 100 miles. So we could say the percent is equal to part divided by whole. 28 divided by 100 is 0.28. 0.28. And if we multiply this by 100, we are back to 28%. So they have traveled 28%, which is, it makes sense. It's pretty straightforward. 28 out of 100 is given. So when we're working with percents, the number 100 is very easy to work with. Okay, number two. The appliance store where the Scott family shops offers an 8% discount for paying cash. The Scott family received a discount of $44. What was their total bill before the discounts? Well, let's translate this into a more direct statement. So they received $44. Now, where did that come from? So 44 is, well, it came from 8% of the total. So 44 is 8% of, well, the total bill. That's what's unknown here. That's what we're looking for. So 44 is 8% of what number? Of what number? 44 is 8% of what number? Okay, so certain words translate always the same way. We know is, that's a very common one. Is means equals. And when you have the word of followed by a number, whether you know that number or not, when you have of followed by a number, that means multiplication. Of is multiplication. Of followed by a number is multiplication. So we have 44 is equals 8%. So let's get that back. Okay, 44 is 8%. So 44 is already a number. 8%, well, let's remember, percentages are not numbers. So to convert that to a number, it needs to be a decimal. So 8% is 0.08 of is times, we said is was equals, of is times, and what number? Well, that's the unknown. In algebra, we use symbols as a temporary placeholder for an unknown. We could use the letter N, we could use the letter X. Basically, you could use any symbol you want. I'll stick with the most common one, which is the letter X. So X is that number. So if 44 is 8% of what number? So we want to isolate the X. You want to get X by itself or solve for X. So we have to divide. The opposite of times 0.08 is divide by 0.08. And whatever we do to one side, we of course have to do to the other side. So on the right-hand side, the times 0.08 and divide 0.08, they will cancel. And on the left-hand side, 44 divided by 0.08. 44 divided by 0.08. And if we pop that into the calculator, you will get 550. So from this, we know the total bill bill was $550. It's always good to state your solution as in the form of a sentence. Okay, so that does it for number 2. Now let's move on to number 3. Number 3 is a little bit more visual than the first couple of problems. Okay, a rectangular garden has vegetables planted in a 35-foot by 20-foot area. So let's start with that. A 35-foot by 20-foot area. Okay, so this is 35 feet. This is 20 feet. And of course, if the left is 20, that's also 20 on the right. If the bottom's 35, the top is 35 as well. Feet. Okay, so a rectangular garden has vegetables planted in a 35 by 20 foot area. The vegetables are surrounded by a 2-foot border of flowers. Now, what does this look like? The vegetables are surrounded by a 2-foot border of flowers. That means there's a border that goes around the garden. It looks something like this. Maybe not drawn perfectly to scale, but that's okay as long as we label everything correctly. Okay, and it's a 2-foot border, which means, again, sorry about that. It's a 2-foot border, so the distance from here to here is 2 feet. And if there's 2 feet on the right, there's also 2 feet on the left. So I'll say 2 feet in this direction, and there's 2 feet on the top, 2 feet, and we've got 2 feet on the bottom. So how big is the red rectangle? So what is the distance from here to here? Well, if we look at this, we have 35 right here. This is 35 feet. Plus we have 2 feet over here, and we have 2 feet over here. So 35 in the middle, 2 feet on the left, 2 feet on the right. So it looks like we have a total of 39 feet. And the same thing in this direction. Because if we're going to calculate area, the area of a rectangle is length times width. So we need the length and we need the width. So again, it's let's use black this time. If this is 20 feet, then you've got another 2 on top and another 2 on the bottom. So 20 in the middle, 2 on top, 2 on the bottom. That is a total of 24 feet. So we started off with, let's bring it over here. We started off with the blue rectangle. That was 20 by 35. So the area of the blue rectangle, 20 times 35, which is 700 square feet. And now the problem says, by what percent is the area for planting vegetables increased if the 2-foot border of flowers is removed? Meaning we could use that extra 2 feet for planting vegetables. Okay, so now we have this larger rectangle, and we said, okay, well that is 24 by 39. And so the area of that larger rectangle, again, length times width, That's 24 times 39. And with the help of a calculator, that is equal to 936 square feet. Okay, so we went from 700 up to 936. So that's an increase. That's an increase of 236 square feet. But the directions don't say how many square feet was the increase. The directions say by what percent. By what percent did the area increase? All right, so we went from 700 square feet and we went up to 936, which means we went up 236 square feet. Now we have a formula for percent change. What was the percent increase? That's what we're basically looking for here. What was the percent increase? And percent increase is equal to the total difference, or the total change, divided by the starting amount. Divided by the starting amount. Okay, so the total difference, that's the 236, and the starting amounts, that's the 700. And with the help of a calculator, if we divide 236 divided by 700, that will give us about 0.33 or 33%. So the increase of 236 square feet meant an increase of 33%. Okay, let's shrink this down a little bit so we could see everything. All right, so we had there was a number of steps here, and it's just important to be systematic in the way you approach the problem. If we're talking about the difference in areas, you know you have to start calculating areas. So we have a small garden, then we have a large garden, so we need the area of each one. That's what we did here and here. Then we came down here and applied our formula for percent increase. Okay, that does it for number 3. Let's do one more on this video. Let's look at number 4. Very similar problem in some ways to number 3. We're looking for percent decrease. So percent increase, percent decrease, it doesn't matter. So the general formula is percent change. Now that change could be, so that's difference divided by starting amount. So that percent change could be a percent increase, could be a percent decrease. Either way, going up, going down. If it's percent increase, if the percent's going up, it's positive. If it's going down, it's negative. Now we could describe a percent decrease by a negative sign, like -6%, or we could use the word down or decrease, like it went down by 6%. Either way works. Either way works. Okay, so let's see. All 30 students in a mathematics class attended class on Monday. On Tuesday, only 25 of them attended. Okay, so we went from 30 down to 25, and so the difference, or the change, was down 5. what was the percent decrease? Okay, well, percent decrease is the difference. It went from 30 down to 25. So that's down 5 or negative 5 divided by the starting amount, which was 30. So the change is on top, down 5. Starting amount is on the bottom, that's 30. And if you pop that into a calculator, negative 5 divided by 30, you will get, you'll get about 0.17, well, negative 0.17, which is negative 17%. So we could say the percent decrease was negative 17%. Another way we could say this is down by 17%. Either way, both ways make sense. Okay, that about does it for number 4. I'm gonna do the other 4 problems, numbers 5 through 8. I'll do those on a separate video. Okay, so that's it for now.